Hello everyone, just a quick video about this goofy little servo tester I made. It features, I don't know if you can see it there, but it's that dip chip right in the center there, the PIC 12F683, which are remarkably cheap. Obviously just a cheap Chinese servo. Mind the messy bench, I just finished soldering and everything. It's a pretty crummy little servo, and just like a stereo, not a stereo pot, but a linear potentiometer. So you could potentially mount this in a little case or something like that. This thing is very simple in design, so I'm going to turn the, I don't know if you can see it rotating. Here, let's put something else on it that shows up a little better. Hang on. This is wonderful videography at its best. Let's see here. There we go. Now we've got this little doodad here instead of the circular one. And this way we can see. Let's try to line it up to the center point. I don't know where that is, but we'll find it. Here we go. So now you can see it at one side of the limit. There we go. There we go. Very simple. And all I'm doing is, I should actually get a knob for this thing, but just turning it. You can hear it in the background. As you'll see, it's here's the terminal for the potentiometer. The center one is actually the actual divided voltage. And normally you could put power in here. I wouldn't exceed 5 volts unless you decide to put a power regulator on it, either switching or non-switching. You see these loose wires, that's why I used to program it. And then they go onto those onto these these headers here. I had to take them off because it was interfering with the signal. Like, I couldn't program it anymore. Because the divided voltage is tapped into the data line on the same chip. And as you well know, if you do little RC servos, the center point is at 1.5 milliseconds, and by dropping it or increasing it by 1 millisecond, so let's say you want to turn it 90 degrees one way, then you drop it to 500 microseconds, or half a millisecond. You can also, if you want to turn it the other way, you can increase it to 2.5 millisecond delay. And that's how that works. And I believe there is a certain deadband. These cheap ones, I think, they say it's 4 microseconds, but I doubt that. There's a certain point to where it won't react anymore, so it's not wasting energy, but it's always, oh, snappos. But these servos are always watching a little potentiometer that's inside. So I didn't have to, I'm pushing it, and it's resisting me. It's resisting my actions. But not very much. There's a bit of a dead band. You can see the gears inside working. And I used a proto board for this, as the camera go in focus. Absolutely stunningly beautiful. Not really, but I used the gloop together method to solder this together. I initially started using wires, and I found it kind of inconvenient to do that. So I just kind of looped it together along the paths, and it seems to work out well for this board. I've used other boards that supposedly are made for that kind of thing, and it was not pretty. I had to use way too much solder. I think it has to do with the lack of solder mask. And, well, these boards have no solder mask, the other ones do, and therefore they don't have as much propensity to drop across the copper pads. And yeah, it's a simple one to make. There's other ones that are on the net. They're 555 timers or specialized ICs for it. This is one you can make if you have a, if you have a PIC programmer. I mean, it's definitely easy to make. I think I used a CCSC, and I think in total that is the code. I mean, that was just quick, right? I wasn't going crazy trying to make it good. You could add a switch. To run it through a test pattern, things like that. Adjustments, you could easily put a couple of pins on here to a max 232. Put a couple of headers and out to a little board with a max 232, and that would you could communicate with it serially and see what the values are, and you could even put a potentiometer on this, compare it with this, and see how much difference there is in between the two in terms of responsiveness and whatnot. I mean, not that these are fantastic devices, but somehow I think that these ones are positionally lacking, and they don't seem very good, and they're kind of noisy. But what do you get? I mean, I paid. See, it even goes past the end point. It could be my fault. I don't know. You hear that little hum? That's the motor trying to seek position. But yeah, nothing spectacular. I've got it decoupled. I did put a diode here. You can see it there. I put a diode there backwards across the positive and negative, just in case the inside of this doesn't have a flyback transistor in that direction. Otherwise, what you can get is huge spikes coming through backwards into the lines, and it can really, well, in some cases, it can burn out your microcontroller. At least that's what I found. Yeah, no, I put not a decoupling cap, but something to, make sure that the drain isn't too heavy. Anyways, hope this was at least somewhat informative. Who knows? There's lots of little projects like this on the net, and if you want the hex file, just give me a comment or whatnot, and I'll send you the hex file. Right, for those of you that don't have a C compiler, at least for this one anyways.